Okay, we talked about polynomials yesterday and putting them in standard form and then naming them by degree and by the number of terms. And today we're going to talk about what is called end behavior. Of polynomial graphs. End behavior of polynomial graphs. And there's going to be 4 types of end behavior. All right. So when you're talking about these polynomial graphs, you could have a graph that looks like a parabola. All right. The end behavior of this graph is up and up. Because at the ends, it's going up. Kind of self-explanatory, huh? The end behavior of this graph is down and down. Pretty tricky so far, huh? The end behavior of this graph this is down and up. All right, we look at it from left to right. We look at the graph from left to right. So furthest to the left, this thing's going down. Furthest to the right, it's going up. So it's called, the end behavior here is called down and up. And then finally, you could have a graph that looks like this. And this end behavior would be up and down. Pretty clear so far? All right, so we're going to draw a table now. And this table is going to allow you to look at the leading term of a polynomial and determine the end behavior of its graph. Got it? So this is called end behavior with leading term ax to the nth power. End behavior with leading term a times x raised to the nth power. And here's how this works. When a is positive, and n is even. When a is positive and n is even, we've got up and up. When a is positive and n is odd, we got down and up. when A is negative, and N is even, we got down and down. And when A is negative and N is odd, we got up and down. So what you're going to be given today is a polynomial function, and you're going to be asked to consider the leading term and determine the end behavior. All right. Now, you have to make sure that your polynomial is in standard form. And remember from yesterday, standard form means that the highest exponent goes first. The highest exponent's got to go first. So if we just leave this table right here, and we've got y equals 4x to the third minus 3x. Here's your A. Here's your N. So in this case, your A is positive, right? And your N is odd. So what's the end behavior? Down and up. Down and up looks like this. A is positive. The 4 is positive. The exponent is odd. So A is positive, N is odd. That's down and up. Let's say we get y equals negative 2x to the fourth plus 8x to the third minus 8x squared plus 2. Nothing matters after the first term, does it? No. You just have to make sure that the leading term has the highest exponent. So now we've got an A that's negative, and we've got an N that's even. Down and down. This is it, buddy. Yeah, this will be on the test. So the test is basically full of this. Yeah. So if it's not, so let's say if it was y equals 2x negative 2x to the third, then equals the 8 first. Yes. Yes. If you're given this, let's say that y equals 2x to the third minus 7x to the fifth plus 6. You're going to use this as your leading term. Or you're going to rewrite it in standard form as negative 7x to the fifth plus 2x to the third plus 6. Now it's in standard form, right? It's up to you. So now your leading term's negative. We got an A that's negative, and we got an N that's odd, and that's up and down. All right, so it would look something like this. All right, it's as simple as that for today. Now, don't write this down, just watch. Do you see this graph that goes up and down? Do you see these peaks and valleys here? Those are called turning points because the graph turns directions, right? It changes directions. They're called turning points, and we're going to talk about those after Thanksgiving. Clear? Your assignment for today is page 285. We're going to do 20 through 31. Through 31. Going to do a study guide tomorrow, and your quiz is going to be on Thursday this week. Study guide tomorrow, quiz on Thursday. I'm going to be here, but we're going to have a quiz on Thursday this week.